Welcome back. So this is the next chapter, that is statistical quality control. So first in this chapter we will be doing the definition of SQC, product control, acceptance sampling, quality control, variance due to chance causes, variation due to assignable cause, advantages of SQC, process and product control, variables, defect, attribute, defectives, determination of quality standards, and all of that. So first off, in this chapter we have four charts. So first is the X bar chart, next is the R chart, and then it's the NP or D chart. So in X bar chart, we need to know that there are two deviations, that is standards given and standards not given. So this is class limit, lower class limit, and upper class limit. Class limit standards given is X bar, and then X bar minus A sigma dash. For upper class limit, it's X bar plus A sigma dash. It's just the changes in the signs. And for standards not given, it's class limit is X double bar. For lower class limit, it's X double bar minus A2 R bar, and X double bar plus A2 R bar. So here we find X bar is equal to summation X by N, and X double bar is summation X bar by K. Okay, so next is the R chart, that is for range. So X bar chart is for mean or averages, and R chart is for range. So class limit D2 sigma dash. For lower class limit D1 sigma dash. UCL is D2 sigma dash. For standards not given, its class limit is R bar, lower class limit is D3 R bar, upper class limit is D4 R bar. And NP or D chart, and here you find R bar, that is summation R by K. So NP or D chart is for defectives, and C chart is for defects. So NP chart, class limit for standards given is NP dash, and NP dash minus 3 square root of NP dash Q dash, and upper class limit is NP dash plus 3 square root of NP dash Q dash. And for standards not given, class limit is NP bar, lower class limit is NP bar minus 3 square root of NP Q bar, and NP bar plus 3 square root of NP Q bar. So here P bar is found by summation D by NK. D is defective items and NK is observation in K samples. This is summation D by NK. Okay, so that's NK. And the last chart is the C chart, that is for defects. So here the control limits are lambda dash minus 3 square root of lambda dash plus 3 square root of lambda dash. And for standards not given, it's C bar minus 3 square root of C double bar, C bar plus 3 square root of C double bar, where C bar is summation C by K. So these are the four charts. We need to know these four charts, only then we will be able to solve the problems and find if it's standards given or standards not given. Let's go through it once more. Okay, X bar chart, class limit is X bar, lower class limit is X bar dash minus A sigma dash, upper class limit is X bar dash plus A sigma dash. It is just the change in the signs. It's one and the same, but it's just the change in sign. For lower class limit, it's minus, and upper class limit is plus. Low comes below, so it's always a subtraction, and upper class limit is above, so it's always plus. Remember that. And standards not given is X double bar minus A2 R bar, and X double bar plus A2 R bar. That is X bar chart. I hope this is clear and you have no doubts at all. And this is always for mean and averages. Okay. And the next one is R chart. So CL is D2 sigma dash, lower class limit is D1 sigma dash, and upper class limit is D2 sigma dash. The first one is small and the other two is the caps. For standards not given is R bar, and lower class limit is D3 R bar, and upper class limit is D4 R bar. So X bar is summation X by N, and X double bar is equal to summation X bar by N. Okay, this is for range because it's R chart. R is for range, X bar. Okay, mean is always represented by X bar, so X bar is always for mean and averages. Okay. And the next one, once more, NP chart is for defectives and C chart is for defects. Okay, CL is NP bar, np bar minus 3 square root of np bar q, np dash q dash, and np dash plus 3 square root of np dash q dash. The line on the top, like 1 is dash, okay, and this is bar. Standards not given is np bar minus 3 square root of npq bar, and np bar plus 3 square root of npq bar, okay. Then it's C chart for defects. Class limit is lambda dash for standards given, lambda dash minus 3 square root of lambda dash plus 3 square root of lambda dash. For standards not given is C bar minus 3 square root of C double bar, and C bar plus 3 square root of C double bar. So we just go on with the definitions and all of that. Statistical quality control, it is a method of controlling the quality of the products using statistical techniques. Statistical process control, it deals with the problem of studying whether the process is functioning properly or not. Suppose there are various processes in an organization. Suppose you take an industry or any organization, there is production, management, selling, marketing, and everything. So the top management has to always ensure that all the processes are going according to their plans, and not according, it's not, they have to ensure that everything is going in order. Acceptance sampling is where it determines whether a batch should be accepted or rejected. If there are like defective goods, it should be obviously rejected and replaced. Quality control is an unsystematic inspection or verification of the quality of products. Variation in quality, it may be due to chance cause and assignable cause. It may come for 1 or 2 markers. Variance due to chance causes, there is no specific cause, okay. There's a small amount of variation, but there's no specific cause for the variation. That is variance due to chance cause. And variation due to assignable cause is when the variation can be observed in the quality of the product. Suppose we use any brand. Suppose we are very addicted to a clothing brand or something. You just blindly go for the product because you believe in the quality of the product, and once you find the quality has deteriorated or there is some defect in the product, you start having second thoughts about choosing the products. So that's due to assignable causes. So advantages, the producer can guarantee the product with confidence to improve the quality, to decrease the production of defectives. Process control is controlling the quality of goods during manufacturing process. Product control is the process of inspection of manufactured lot for acceptability. Variables is a measurable quality characteristic which varies from unit to unit. Attribute is a qualitative characteristic which cannot be measured. Okay. So variables can be all the sales figures of a company and all of that. Attribute is beauty, knowledge, and all of that. Defect is a quality characteristic which does not conform to specification, and defective is when one item is having one or more defects. Okay. Then construction of control charts, there are 3. There's central line, lower control limit, and upper control limit. So these are this class limit, lower class limit, and upper class limit. The one in the center is the class limit, that's the average line. Upper class limit comes on the top and lower class limit comes on below. Okay, you need to always draw your x and y axis, label them, name your x and y axis, then you get the entire 2 or 3 marks. If it's asked, it's not asked normally. Okay. And then we did all the charts. Now we go ahead with the okay, we'll just do the interpretation of control charts. The purpose of using control chart is to detect variation due to assignable causes, and if no points be outside the control limit, the process is under control. Okay. Then it is the acceptance sample. The manufacturer lot will be accepted after inspection and confirmation of the quality standards. In acceptance, there are 2 methods. There is single sampling and double sampling. The advantages, it is used when items are destructive, and it is less expensive as 100% inspection is more expensive. And disadvantages, timely identification of the production of defectives, and there's risk of accepting a bad lot and rejecting a good lot. So single sampling plan, the decision about accepting or rejecting a lot is based on only one sample. They do not consider the entire lot. Okay. Relative merits and demerits. SSP is easier and simpler than DSP. In DSP, in case the lot is accepted in the first stage itself, there would be reduction in the number of items inspected. And so on an average, the inspection could be lesser. Then the inspection cost would be lesser. Okay. The sums. So measurements of metal holders for different samples of size 5 each gave the results x double bar is equal to 80.3 and r bar is equal to 5.2. Find the values of control limits for drawing x bar chart and give it a2 is equal to 0.577. So here standards are not given. Okay, wait. So here standards are not given because they've given the value of a2 in the question. So class limit is nothing but x double bar, that is 80.3, which is already given in the question, and LCL is x double bar minus a2 r bar. Okay, so x double bar is 80.3 minus 0.577 into r bar. Okay, so I'll show it to you how to do it on the scientific calculator. So x double bar is nothing but 80.3 x double bar minus a2 is 0.577 a2 into r bar. R bar is 5.2 and the answer is 77.2996. Okay, so that's how you do it on the calculator. And UCL is x double bar plus a2 r bar. The next question, in an electric bulb manufacturing plant, a production manager has inspected a sample of 30 bulbs. So sample is nothing but n, so n is 30. If the average fraction defective is p bar. So defective, when you see defective, you need to always go for the NP or NPD chart. Write out the control limits for the number of defectives. So here standards are not given because it's p bar. So NP bar is nothing but 30 into 0.057. Okay, we'll do that. 30 into 0.057. Okay, so it's 1.71. And LCL is NP bar minus 3 square root of NP bar PQ bar and NP bar plus 3 square root of NPQ bar. The next question, defectives we have done, so we just move on. Question. From a manufacturing process, the data based on subgroups of size 5 each are given below. So the subgroups are 1, 2, 3, 4, 5, 6, 7, 8 and 9. Subgroup sample mean is given and the sample range is given. Find the control limits for mean and range. So for mean and range, it's x bar chart. So here the standards aren't given. So x double bar is equal to summation x bar by r, and class limit is x double bar. LCL is x double bar minus a2 r bar, and UCL is x double bar plus a2 r bar. You need to actually find x double bar, which is equal to summation x bar divided by r. So for the summation x bar, you consider all these values: 3 plus 5 plus 2 plus 4 plus 3 plus 6 plus 4 plus 2 plus 5 divided by the number of subgroups, so that's 9. So 34 divided by 9 is 3.78. Okay. Next, for x double bar, it is summation x bar x double bar. So you need to add all these values divided by the subgroups, so you get 24.28 28888. So any number after 5, it should be rounded off to the next number, so it's 24.289. Okay, and then LCL is x double bar minus a2 r bar, so 24.289 minus 0.577 into 3.78. Okay, already given in the question. And for UCL, it's x double bar plus a2 r bar, so 24.289 minus 0.577 into 3.78. it should be plus, okay, because it's x double bar plus a2 r bar. So these are the answers. And for R chart, standards are not given, so class limit is R bar, that is nothing but 3.78, and LCL is D3 R bar, that is 0 into 3.780. UCL is D4 R bar, that is 2115 into 3.78, that is 7.9947. This question: from a razor blade production process, the following data regarding number of defective blades in a sample containing 100 razor blades each is obtained. Find the control limits. So here the sample numbers and the number of defects are given. So n is 100 because sample is 100, and the number of defectives, when you add all this you get 150. So p bar is nothing but summation d by nk. So summation d is nothing but defectives, so that is 150. N is the number of samples, so that's 100, and k is the sample numbers, so that is 10. Okay, so you get 0.15, and to get p bar is 0.15. So q bar is nothing but 1 minus p bar, so that is 1 minus 0.15, that is 0.85. Here standards are not given, so cl is equal to np bar, that is 100 into 0.15. LCL is equal to np bar minus 3 square root of np bar q bar, and UCL is nothing but np bar plus 3 square root of np q bar. So I am done with this chapter. If you have any doubts, please go down the comment box and ask me all your doubts, and I hope that I will be able to clear them. Thank you. See you tomorrow.